Hello and welcome to PreCalc. Today is Friday, September the 11th. We're going to put the date at the top of our page. And our topic for the day is rational exponents. Let's break down this word rational. Rational just means fraction. Just means fraction. Fraction like ratio. So rational just means that the exponents are in the form of a fraction. Now, when we have a rational exponent, our numerator is the power and our denominator is the root. Let's dive into some examples to see what this means. So our instructions on all of these are convert from exponential form to radical form. Exponential form is like what we see in example 1 here. It's when there's just exponents, and then radical form is when it's back underneath a square root. All right, let's check out our first example. Okay, we got to convert x to the power of 2/5. The 2 is our power, and the 5 is our root. So I have x squared, the 5th root of x squared is just our final answer here. Both these expressions mean the same thing. It is two different ways to express the same idea. Okay, let's go through some more examples. Okay, example 2. I've got x to the power of 1/3. 1 is my power, 3 is my root, so I get x to the first cube root. Generally, we don't have to write the exponent of 1. It is our assumed exponent, so we can just put the cube root of x. Okay, let's look at example 3. I've got x to the 4/5. Remember to pause whenever you need and to always write out the original problem. This is our power. This is our root. So I'm going to write this as x to the 4th 5th root. The 5th root of x to the 4th. Okay? Okay, so now we're going to look at negative exponents. So negative exponents flip whether the main term is in the numerator or in the denominator. So in this case, x starts out normal, starts in a numerator, but the negative exponent is going to cause it to go to the denominator. And then once the negative exponent does its job of moving the initial term, it is now positive. So x to the -2 started off like regular, looking normal. Then the negative exponent caused it to go to the denominator. And once the negative exponent does its job, it is again positive. So these are equivalent expressions. Think about it with some numbers. If I have 3 to the -2, that's the same as 1 over 3 to the 2, which is 1/9. So 3 to the -2 is the same as 1/9. Okay, let's consider what happens if it starts in the denominator. Well, if it starts in the denominator, it must come back upstairs to the numerator. So this is just x cubed. And after the negative exponent causes the term to move, it is no longer negative, it has done its job. If we think about this with some numbers, I could have 1 over 4 to the -2 is 4 to the 2 is 16. So 1 over 4 to the power of negative 2 is the same as 16. Okay, 2 more examples. All right, let's put these all together now. So I've got a negative and a rational. So first thing I'm going to do is take care of the negative. I'm going to say this is the same as 1 over x to the power of 3 over 4, which is the same as 1 over the 4th root of x cubed. So this is our final answer. The negative exponent causes it to move to the denominator. That's the negative exponent's job. Once it finishes its job, it's not there anymore, it's positive, and then we convert our rational exponent into a radical. Last example here, same deal. I've got x to the negative 4/7. I'm going to want to take care of that negative first. X to the 4/7. Now we can convert. I've got the 7th root of x to the 4th. That's all for today, guys. Thanks.